Good evening, my friends and followers. I remain Edward, the tutor in Edward Academy. This evening, I will be interpreting the previous forecasts we did with Arima models. But before interpreting the forecast, I will actually teach you how to evaluate a better forecast among forecasts. So I'm going to go back to a modified version of what we did previously to actually see how to identify a better forecast and evaluate them appropriately. Recall in my previous video I forecasted the value of the Human Development Index in Nigeria from 1981 to 2029, and I actually used data sourced from the World Development Indicator data set of the World Bank Group. So this evening I will refer to six tentative equations that we built before, an extra three, that is total equation identified, and the Arima model is 9 equations. And these 9 equations, you can actually see how I have estimated each of these equations. We identified 9 Arima models. We identify Arima 111. We identify Arima 112, Arima 113, Arima 211, 212, 213, 311, 312, and 313. These are tentative 9 models we identified here, but that doesn't mean that these are the only models here. Like I said before, Arima process is an art, it's not a science. These 9 tentative models, I've estimated them. If you actually go down the bar, you see each of the models estimated. I've estimated them, but I will take you to a Microsoft Word where I have cleared out or cleaned out the results for easy interpretation. So in this Microsoft Word, I actually have all the tentative Arima models. These are the Arima models. We have 111, 112 to 313, and we relied previously on the number of significance. We talked about the adjusted R square, the sigma square, which is the volatility, the AIC, and W1 statistics. So these are the criteria or the condition that I actually want to employ to evaluate or to select the best Arima model at the moment. Arima 111 has one significant coefficient, and the R square adjusted is low. Arima 121 no, 113 no. Arima 211 have R square adjusted that is better than all of the R square adjusted, although none of the variables are significant. While Arima 311 and Arima 312 can be known for having a lower AIC, because the rule of thumb is the lower the value, the better the model. So given the fact that I actually want to evaluate 2 Arima models this evening, I want to tentatively select Arima 111 and Arima 211. So having selected these 2 Arimas, I will go back to my A-view worksheet so that we can be able to forecast the value of these 2 Arimas. Then I will now make evaluations of these 2 Arima models. Back to my A-view. I'm using A-view 10 for this study this evening. I will close down these A-views, these results. Then let me just go to the 2 tentative models I have selected. Arima 111. Here is Arima 111. Here is my Arima 111. So the first thing to do in this Arima 111 is to forecast this Arima 111. But before I will forecast this Arima 111, I will need to set my time frame. Remember, I want to forecast from 2000 to 2029, but my data set spans from 1981 to 2019. So what I will now do is to go to Proc. From Proc, I go to Structure Resize Current Page. I will extend my end date to 2029. I hit the OK button. Yes, I'll click yes twice. Okay, I've extended my end date to 2029. Then the next thing to do is to go back to my Arima 111 model. Go back to my Arima 111 model and do the needful. This is my Arima 111 model. So I will need to focus this model. To focus this model, I go to Focused. I change this HDI focus to HDI focus 1 to identify this particular focus. Then I will change the start date to 2000. I want to start from 2000 to 2029 without changing anything. Our model is a static focus. I will not change any other thing. I will hit the OK button. If I hit the OK button, I will be exposed to a forecasted outcome that looks like this. This is the forecasted outcome for equation 1, which is HDI-F1. The actual observation is HDI, while the forecasted observation is HDI-F1. So let's look at this parameter. The focus sample is 2000 to 2029 rather. After adjustment, we still have 21 observation. So we are going to rely on the root mean square error and the tail inequality coefficient. And the rule of thumb is that the lower the root mean square error, the better the model. So we are going to compare the root mean square error of this first model with the root mean square error of the second model we are going to forecast again. The root mean square error of this model is 0.004748, which means that it is low. And the lower the root mean square error means that the actual observation and the forecasted observation are moving in the same direction, or that there is no disparity between the actual observation and the forecasted observation is too minimal. Then secondly, the tail inequality coefficient ranges between 0 and 1. When the tail inequality coefficient is 0, it then means that the actual observation and the forecasted observations are moving together. But when the tail inequality coefficient is 1, it means that there is a disparity between the actual observation and the forecasted observation. So you look at the tail inequality we have here is lower, but we're going to copy it to a Microsoft Word where we will revert back to it later. So this is my Microsoft Word where I actually want to test the first focus. The first focus, I am pasting it here. Sorry, I'm pasting the first focus here. I'm pasting the first focus here. This is my first focus. Okay, let me go back to my EV worksheet again. This is my EV worksheet. I've saved my first focus as HDI F1. I'll minimize this page. Then the second model I identify is Arima 211. This is my Arima 211. This is my Arima 211. The second model I actually identified because of what I want to achieve this evening. The next thing to be done is to forecast this Arima model. I will change it to 2 HDIF2. Then I will revert to static model rather. Static model, I will change the focus sample from 2000 to 2029 without changing any other part of this. I hit the OK button. If I hit the OK button, I have gotten a different focus, ADIF2. ADIF2, this is a different focus I've gotten. I will still copy this neatly to the PowerPoint or to Microsoft Word where I kept the previous one. This is my previous and my current results. Okay, I will try to join them together for easy comparison. So basically we can look at these two results simultaneously by comparing their outputs and take decisions in line with the appropriate standard. And our attention will be drawn to the root mean square error and the tail inequality coefficient. The root mean square error for the first forecasted equation is 0.004748, while the root mean square error of the second model is 0.004628. and if you look at the root mean square error of the first result, is higher than the root mean square error of the second model, which means that using the root mean square error, the second model is lower when compared to the first model. Then using the tail inequality coefficient, the tail inequality coefficient of the first model is 0.004987, while the tail inequality of the second model is 0.004857, which implies that the tail inequality of the second equation is lower than the tail inequality of the first equation. So both the root mean square error and the tail inequality of the second equation is lower than that of the first equation. Then the bias proportion value for the first equation is 0.089282, while the bias proportion of the second equation is 0.103934. Approximately, the bias proportion of the second equation is greater than the bias proportion of the first equation. So let's move back to our EV worksheet to actually plot a graph of these two models to actually decide on the best model. The final decision is that we're going to plot a graph of the two models with the original HDI. So back to my EV worksheet. This is my EV worksheet. I will highlight these three models, open them as a group. This is HDI 1, HDI focus 1, HDI focus 2. You open them as a group. And okay. If I plot this graph, we plot the graph of this combined HDI, you'll be exposed to a graph that looks like this. But we cannot actually conclude that this graph is better than what we actually intend to do. So we will go back to our previous forecast we'll go back to what we forecasted previously. We will move on to it. Let me see if there is any adjustment that is needed to be done in what I actually forecasted previously. The forecast we did. Okay, if you look here, okay, I'm looking at it again to focus. Okay. Okay. Let's see how far this can go. I'm deleting the previous forecast I did. I want to adjust something. The previous forecast I did, I want to adjust something, deleting them completely. So I'm going back to 211 again. I'm going back to 211. This is my 211. I'm forecasting again. The 2112. Forecasting again. I'm looking at it again. 2000 and going out again. This is my new forecast. This is my new forecast. So let me open them as a group again to see if I will actually find the incorporation of the new variables, the new year, the expanded section of what we actually intend to achieve, because we start incorporating the new period. Okay, what we actually intend to achieve is already here. If you look at these three columns, we have the HDI, HDIF, HDI2. So this is the first forecast, this is the second forecast, and the original data set stopped at 2019, and the extended information began from 2020 to 2029, 2020 to 2029. So actually we have forecasted new series for Human Development Index in Nigeria. The first forecast is this, second forecast is this. Remember that this first forecast used Arima 111, the second forecast used Arima 211. So we are going to plot a graph of these three data set to see how they actually move on. So to do that, we go to graph. From graph we move on to frame and lines. We actually select two-dimensional graph, frame and line. We look at it without any other thing. We hit the OK button. If you hit the OK button, you'll be exposed to a result that looks like this. This is the results. This is how it will actually appear. This is how it will appear. This is the combined graph of the three data sets, the baseline HDI, the first HDI based on Arima 111, the second focus based on Arima 211. So if you look at these graphs critically, you understand that the blue line you are seeing, actually starts from 2000. The red line also starts from 2000. So both the blue line and the red line represents the forecasted series. You will now observe that the baseline model, which starts from 1981 and extend further. The baseline model starts from 1981 and stopped at 2019. This is the baseline model. This blue line stopped here. Then from this particular point, from 2000, we actually have the red line and this other line. So the comparison or the evaluation now is to actually determine which of the forecasted line is very close to the baseline model. The baseline model is blue, and this is the only one that is close to the baseline model. So the closer the model, the forecasted HDI to the baseline model, the better the model. That means that the HDI-F2 is closer to HDI, and that means that Arima model 211 is better when compared to Arima model 111, given the fact that the forecasted value of Arima model 211 is closer to the baseline Arima, the baseline HDI. So this is how we actually evaluate the HDI values for forecasted informations of this nature. So thank you for staying tuned to my channel. In my next video rather, I will be presenting simultaneous equations and other solving requirements which are also part of the forecasting business. Thank you for subscribing to Edwards Academy. I promise in my next video I will actually bring better interesting videos and development in macroeconometrics. Thank you and God bless you.